Dear friends and members of the KITION Planetarium Observatory, good evening. Thank you for being with us tonight, and thank you for watching it on YouTube for those that didn't manage to do so at this time. Tonight we are going to talk about the asteroid days discoveries. Actually, the asteroid discoveries made by the KITION Planetarium Observatory, and it is a subject that is related to the International Asteroid Day celebrations. And as the national coordinator for CYPRUS, myself, I'm going to be speaking about the subject tomorrow at the CYPRUS National Channel, CYBC or RIG 1. It's going to be a live interview at 2:30 in the afternoon. We have posted on our group the links for the live link for you to watch, and we also posted the link that it will then be uploaded by the channel. Tonight we have a special guest with us, Mr. ALEXANDR PROKOFYEV, our astrophysicist. He will talk to you about the discoveries, and he will give an extended description about the families they belong to, and also come up with a review of the 9 discoveries. And he will give you more details during his speech. As I mentioned earlier, on the 30th of June every year we celebrate the International Asteroid Day. The International Asteroid Day is to commemorate the recent history event that we had in Tunguska on the 30th of June 1908, when we had an asteroid or comet possibly exploding over the forest in Tunguska in Siberia, and it devastated 50 kilometers radius of forest. A very large explosion, and it devastated, as I mentioned earlier, the forest, and the blast and the explosion was heard many kilometers away, hundreds of kilometers away. And we have many testimonies that we will in extent talk about tomorrow and at our celebrations on the 13th of June here at the KITION Planetarium. You are all welcome on the 30th to listen about the details about the commemoration of this event, and also observe with us the night sky from our observatory. Before we proceed, I would like to announce to you that as the National Coordinator for CYPRUS for the World Space Week, I was awarded a Global Impact Award for the impact in outreach in astronomy and astrophysics and space exploration. And we are very proud to announce this to the general public. And the award is consulting from the GenSpace company, which they are promoting astropreneurship. And tomorrow we have a meeting with them, which is our award for this win, let's say, and they're going to teach us how to improve science outreach in Cyprus, and to promote even more the projects, and also to encourage, which is the main purpose, to encourage the new generation to be involved in the space exploration. So for those that don't know what I'm talking about, World Space Week is a United Nations declared celebration that is celebrated every year between the 4th and 10th of October. On the 4th of October, 1957, we had the launch of the first human-made Earth satellite, Sputnik Adin. That was the opening of the space exploration and space race, actually. And 10 years later, we had the signing of the Treaty of the Principles of Governing the Activities of States in the Exploration and Peaceful Uses of Outer Space, including the Moon and other celestial bodies. So that was 1967, 10 years later. So the celebrations are always between the 4th and the 10th of October every year. So don't forget to get your tickets to book your place here. We are celebrating the 10th year anniversary this year for Asteroid Day, and that's why we have the special logo. And this is a program for our event. It will start with a welcoming talk from me, and then we are going to talk about the International Asteroid Day movement in Cyprus and abroad internationally. We are going to present also our new discoveries, part of what you're going to see tonight and furthermore on that night. There will be an asteroid movie talking about the distractions from asteroids, what happened to the dinosaurs. Of course, the dinosaurs didn't have the technology we have today, and it is important to search for asteroids, to track them, and try to protect our planet from them, because some unwanted impact may create some issues to our planet, the Earth. And after the movie finishes, we will do some telescope observations. We will observe a beautiful star cluster in Hercules, and all these observations will be done from our observatory, and it will give you a hands-on experience with the telescope inside the dome, and you will observe the marvels of the night sky. Alexander, thank you very much. The stage is yours. So Alexander now will give you the details about our asteroid discoveries. And if you want to get your tickets, to book your place for that, you may go to the website, astronomycyprus.eu. You may press the link on Asteroid Day. It will let you to the gift shop, and you can book your tickets for Monday the 30th there. Remind you, don't forget to watch us tomorrow, CYBC channel 230, a live broadcast. And I will give a talk on Asteroid Day, extensive talk with more details, and I will be accompanied by Mr. Konstantinos Trouillias, the analog astronaut, our analog astronaut here at the KITION Planetarium Observatory, who represented Cyprus, and it's the first worldwide first solo mission that the Analog Astronaut Training Center didn't have any data from a single man mission until that time, 2 years ago. Therefore, he achieved something really important. Of course, mainly was the psychological part, and then he had to fight with his biological clock to concentrate, because they, as soon as they enter the habitat, they turn off the watches, no clock inside, complete darkness, it's time zero. They don't know what time it is outside, so they have to go everything by time zero and count minute by minute to do their tasks and make their record on the logs. And of course, carry out the experiments they are put to do during the mission. So that was mission 66, expedition 66, named Augusta or Augusta, which means divine. Thank you for your time. And now Alexander will share his screen to talk to you about our latest discoveries here with our research team in cooperation with NASA, Artesian University, and Cisco College in Hawaii. Alexander?
Thank you very much. And I want to start with announcement of the next Science Cafe, which is going every month at the end of month, every Tuesday. George, can you say a few words? Because of you, we may reveal secret who will be the guest.
Okay. Give me a second so I can find everything about our guest, Alexandr. She's an astrophysicist. So the next one will be the last Tuesday of July, and we'll have a very, very special guest. She's going to talk about quantum photonics. Evie Alexandri, she's a Cypriot, and she has received a Bachelor of Science in Physics, Master of Science in Physics, and she did her dissertation on free electron lasers, and she's a PhD candidate, very near the end actually to achieve her PhD, and she's studying quantum photonics. So a really interesting subject, a unique subject, and a unique experience because Evie Alexandri, she started from the KITION Astronomy Academy. Actually, she was a student here at the beginning as she came with her school to do her internship, to experience 1 week at Science Center from the age, if I remember well, from the age of 15 or 16. And now she's a PhD candidate for quantum photonics. And we are very, very proud of her. Hopefully she will manage to connect later on because she's really busy with her project now. And if she manages, she will be with you tonight. If not, we will see her at the next Science Cafe on the 29th of July, 29th of July, the same time.
Thank you. So let's have a look at in a part of solar system. We see here the sun, few planets, asteroid belt, our main reason to why we gather today, and Jupiter with some more asteroids on its orbit. So this is what is interested for us. This is the oldest planet. Jupiter, it occurred to be the oldest planet in the whole solar system. All the star, the sun in our case, and planets, they appeared almost same time. Almost, but not precisely. Jupiter occurred to be the first. Maybe that's why it is the largest. And here is a scientific research which was made in 2017, which indicate the reason why we know that Jupiter is the eldest planet. We use, to estimate it, we use meteorites. And in the KITION Planetarium Observatory, when you visit us, you will see some meteorites as well. This is one of them. And this is iron meteorite. And in this article, it was iron meteorites gathered not only from one place like this one from Argentina, but from all over the world. Hundreds of meteorites were used, were estimated, examined accurately, and it is meteorites that gave answers that Jupiter was the eldest. It appeared earlier than all the rest. And at the beginning, its mass was 20 masses of the Earth. Now it's 300 masses, but it was beginning. Not all 300 were collected same moment. In 2015, in Cyprus, there was an international conference, This Dynamics and Planet Formation. And these three people were the main people whose vision made this conference happen. And this is a poster of the conference with topics. And there was an expedition as part of the conference. And at that expedition, we saw a shell, image of shell. It is human-made all times. And this image is shell is dedicated to Aphrodite, the goddess, according to Greek mythology, was born at Petrotoromiou here in Cyprus. And this is part of our poster with topics. And you see there is planet migration. So in 2015, I took participation in that conference and I learned a bit more than I will discuss now about planet migrations. So it occurred that at the beginning, planet migrate. They don't migrate now, but at the beginning it was. And the way how planet migrated were published, for example, in 2011 when we discuss how Jupiter, the first planet which appeared those days when the article was published in 2011, it was not known that Jupiter was the first. It was known that Jupiter migrated, but it was the first. So what happened? How it appeared? So we'll discuss 4 stages. The first one is the moment when Jupiter was formed. Maybe other planets was not, but Jupiter was already 20 masses of the Earth. And it was not in empty space like it is now. Now it is in empty. And that's why nothing could happen with Jupiter, with the Earth and all other planets. For a billion of years, they are at the same place, at the same distance from the Sun. Here we have distances from the Sun, and we measure all distances in astronomical units. It is average distance from the Earth to the Sun. So 1 astronomical unit is for the Earth, about 5 astronomical units for Jupiter, about almost 10, 9 something is for Saturn, and so on, all other planets somewhere in their places on the scale. Well, so the Sun is at 0, that's why it's bright here. Well, let's start. Jupiter appeared when it was a distance about 3.5 astronomical units from the Sun. It was the only planet. All the rest were absent, and these small circles, which are all over the disk of solar system, were planetesimals. It is small bodies, they are some hundreds kilometers size, or larger or smaller, something like that. They are definitely not planets yet, but it is clumps collected from gas and dust together. The Sun was not yet, it was protostar in center, and it was cold. Maybe it was hot inside, but cold outside. That's why gas fly everywhere. Everywhere there was gas. And it is this gas which make the migration possible. Interaction of Jupiter with gas here and here brought to the movement of Jupiter inside solar system, and it moved. So when it was 100,000 years, it reached almost modern Mars position, 1.5 astronomical units. So it arrived to this place. Meanwhile, during this period, Saturn appeared, and it moved as well to the inner part of solar system, but not only moved inside, it collected material on itself, and as a result, gap in this place occurred. And it is this gap that it means that interaction of Jupiter with gas goes everywhere. A part of this gap, there is no gas anymore. Saturn collected it. And Jupiter, this non-symmetrical case, brought Jupiter back, and it started to move backward. So it's really interesting because of without Saturn, Jupiter will continue its movement towards the center of the solar system, and it will become hot Jupiter, as we know in many other planetary systems. But it was not. Saturn appeared and it moved, and because of this, it moved Jupiter back, and Saturn moved back as well. So as a result, in 300,000 years, Jupiter was at this position, and then it returned, occupied modern position, and since that time it is till now at the same place because of gas vanished, the Sun became hot, all gas was spread, go away. Now the solar system became completely transparent, no gas, almost no dust, and nothing could move Jupiter or other planets in their positions. But what's important, this motion of Jupiter toward inner part of solar system and back brought to one important point for us. No planet could appear here. There was place for it. Planetesimals wanted to gather and create something, but Jupiter, because of it was the first and it became massive, and it mass increase. With this huge mass, it did not allow anything to be created here. Its gravitational pull did not allow it to appear a new planet. So that's why we have 4 planets, no planet here. And what's left? If there is no planet till now and no gas, no motion of these bodies anymore, and these bodies produce later our main asteroid belt. That's what we have it now. And that's the reason why we don't have planet anymore. So that's beginning of solar system. And we know, as George Trouillas already mentioned, asteroids. One of them, 35 million years ago, met with the Earth and brought to extinction of dinosaurs. That's why it is important for us to know all asteroids, where are they and how they fly, and maybe there is one more impact in future with the Earth. So that's why we started to take care about asteroids very accurately, very attentively, and we learn now that there are more than 1 million asteroids. Those which we are discovering now have size about 1 kilometer. Could you imagine? The very first has size 950 kilometers, almost 1,000 kilometer size. Now we are discovering 1 kilometer size. So that's the development of technology in the last 200 years. Let's discuss what does it mean orbit of celestial body. Any celestial body goes around the sun, if it is in the solar system and not the sun, of course. And they go on elliptical orbit. It is elongated, not circle, elongated shape. And there is nearest position of it, which we name perihelion, farthest position aphelion. For example, the Earth will be in the farthest position 4th of July, very soon, in the midnight Cyprus time. And so we are here, but soon we will come to this position with the Earth, if it is orbit of the Earth, or if we discuss any celestial body, it is like this. And the longest possible distance in the ellipse, we name it measure axis, and this part, half of it, we name semi-measure axis. In fact, it is very important value. It is this value which indicate average distance from the celestial body to the sun. And as you already know, it is 1 astronomical unit for the Earth. If we measure it in kilometers, it will be 150 million kilometers. So 2 astronomical number to remember. That's why astronomers prefer to use just one astronomical unit. Okay, simple. One more thing which we need to know, it is inclination of orbit of celestial body. This is the plane of the Earth, how it orbits around the sun. But not everything orbit around the sun in the same plane. We are created from the same disk, and generally all planets go along the same plane, but nothing is perfect, and that's why there is some tilt between orbit of celestial body and our own Earth orbit. This tilt, we name it inclination. There are many other names here. We don't care at the moment about them. We care about inclination only. So when we have a body and inclination is small, it means that it's practically in the disk of the solar system when it was created. But when inclination is large, it means that the body it belongs to the solar system, of course, but it has something. It's not directly connected to these large planets of which orbit the sun. Well, let's discuss asteroid families. There are many asteroids. Now we know that there are more than 1 million of them. And if we decided to arrange position of the asteroid from the sun in one scale, and how it orbit tilted to the Earth orbit on the other scale, then we will mark the point. Our asteroid is here. For example, Vesta is here, an asteroid. Ceres, the first asteroid which was discovered, is here, and so on. So I could not name you all 1 million asteroids, where are they? But you see that they create groups. And these groups, we name them asteroid families. So this becomes interesting. More than 100 years ago, this plot was created, and as a result, we got now beautiful position. We discussed that there are some asteroids which group together, which orbit practically share the same orbit, and there are many of them at the same place. How they were created, these asteroid families? You remember that at the beginning of creation of solar system, there were many planetesimals, and they orbit around the sun inside gas and dust, and sometimes they may collide. Okay, what happened next? When Jupiter went away and took its position like it is now, asteroids appeared at the place where there were planetesimals already, and some of them, when they meet with each other after the collision, they fragmented. Instead of one planetesimal, now we have many smaller bodies, and these bodies generally go around the sun, sharing almost the same orbit. And being so, because of they share almost the same orbit, they created, as I said, asteroid family. So many asteroids which orbit almost the same place, they have belong to the same asteroid family. But what is it planetesimal? This planetesimal is already few hundred kilometer size body. Now it is decayed, and we have many asteroids instead of it. But this asteroid consists of the same material from which planetesimal was created at the beginning. So if there are a lot of iron in this planetesimal, then we have iron asteroids. If there are a lot of carbon in this planetesimal, then we have carbon asteroid. So they don't only share the same orbit, they share the same origin. They have the same, they were created from the same material. This is most important for us. Asteroids which were discovered by the KITION Planetarium Observatory this discovery started in 2019. The first one was AN16, 2019 AN16. These are the names of the asteroids. Names are very simple. The first four digits is the year of discovery, then follow 2 letters, and then number, usually short number, 8, 16, sometimes long, like 188. Anyway, these are the asteroids which were discovered here. This is database where you may check any asteroid which you want, and this as well. There are 2 databases. Center of Minor Planets, it belongs to International Astronomical Union, and Horizons, which belongs to NASA. And any of them could be used. They are really useful. Instead of saying during our talk the names 2019 AN16, I would use name 1 or 2 or 3. It's a bit shorter. Yes, this is the name of asteroid, but it's too long to pronounce. That's why I gave name 1, 2, 3, 4, 5. So that's the name of our asteroid. So if we go to Minor Planet Center, we will find out that asteroid 2019 AN16 has distance from the Sun 2.6 or something like that as astronomical units, and inclination 30 degrees. Okay, let's put our asteroid 2.5 actually astronomical units average distance from the Sun, and an inclination. You remember our graph was up to 20 degrees, but unfortunately our asteroid number 1 in our name has even 30, so I had to prolong this scale and put our asteroid here. So 30 degrees. So this is our first asteroid. Second asteroid is next to Evnomia, and it's definitely a group. So maybe it belongs to this group. Third asteroid is in the middle of nowhere. Fourth asteroid again in the middle of nowhere, and so on. So we will discuss all of them step by step. Which asteroids you think are at some group? If you could not say, you may type in the chat. Okay, let's return back. 7, look, it's definitely close to a group. What else? 2 already very close to the group. All the rest maybe not. 5 may, if this is a group, then maybe it belongs to a group, but others don't look. Okay, let's start to discuss each of them. So asteroid, which I gave name 1. 2019 IN16. It was the very first asteroid discovered by the KITION Planetarium Observatory. In fact, not all groups are shown here, obviously, because of this part was missed in our drawing, but we have Phocia family, and this Phocia family, our asteroid indeed belongs to it. It is S-type. S means stony, so it's stone asteroid. The planetesimal was already developed, change its inner structure and become stone. And now it decayed, so we have the largest asteroid which is flying instead of that planetesimal Phocia. And all of these asteroids are stony. And the average density is really dense, 3.0 grams per centimeter cube is dense material. It's more dense than average stone, basalt, in which Cyprus is made. And it is really interesting asteroid, so it belongs to this group. Let's go further. Eunomia family. I put question mark because of these asteroids indeed are S-type asteroids. The average density is 3 grams as well, but despite of this is group, we know that Eunomia has group. There are many asteroids which share the same orbit because we have 1 million of them. Some of them fly next to Eunomia and they share almost same orbit, but they don't belong to this group. They could be darker or brighter, so they don't belong. How to check if our asteroid 2019 JW8 belongs to Eunomia group or not? It's simple. We may check by spectrum, and we will find out if this asteroid is from Eunomia or not. Anyway, this asteroid may belong to Eunomia family because of it's really very close to it. Well, and asteroid which got name 7, so just because of it was discovered the 7th in the row, so 2019 CJ48. So here it is. It's if it belongs to Themis family, then it should be C-type, so carbonaceous type. All these asteroids are very dark, really very dark. It's as dark as charcoal, which we have on the Earth when we make Suvla, for example. So this black charcoal has similar color, similar type as this C-type asteroids. So they are really dark, and because of they have a lot of carbon materials, which is not very dense, that's why the average density is very small, 1.7 grams per centimeter cube, is like not very dense stones which surround us in Cyprus, especially far away from mountains. So it is not very dense material. So that's what we have with our 3 asteroids. The first, the second, and the 7th. All the rest, we name them, they belongs to main asteroid belt without discussing to which family they belong. There should be dots somewhere, so our asteroids just among these dots. So that's what we have for our asteroids. All the rest don't belong to any family. Okay, so let them fly. Maybe they belong to some of them, but then during collision with other asteroids, they lost their history, and now they are just flying everywhere. Age of asteroid family. It is another scientific publication. It was made recently. We discuss the first 30 families, which are recognized by all scientists. There are many more. Now we have almost 100 families of asteroids, but not all of them have a lot of asteroids, and that's why we are not pretty sure whether it is family or not. That's why future research and future discoveries are waiting, and they will finally tell us if this is family or not. But we already distinguish 30 for sure asteroid families. And here, for example, 24, as it is explained, it is our family which the seventh asteroids belong to, maybe. It is Themis family. So Themis asteroid. So 24 stays for 24 asteroid which has named Themis, and so on. So many of them, because of at the beginning large asteroids were discovered, and we give to asteroid family the name of the largest there. That's why you may see that most of numbers are very short, very small, sorry, just 1 to maybe 3 digits. Occasionally there is very long one, but most of them are small because of this. The largest asteroid were discovered first, obviously. Now, these days, as I already said, we have good technology to discover asteroids which have size 1 kilometer only. Well, so let's put our asteroids in this group. So our asteroid number 1, so which belongs to Fokia group, it is here. So if it belongs to this group, and it belongs, so about this we know for sure that it belongs. So our asteroid has age about 2 billion years. It's incredible. Our asteroid was created 2 billion years ago. That's what we know. Asteroid 2, if it belongs to Eunomia group, it is here. Then it was younger, maybe about 1.5 billion years old. So this is about our second asteroid. About asteroid 7, 2021 CJ48. It belongs to the oldest, if it belongs, of course, asteroid family. Its age should be about 3.5 billion years. So it's really very, very old. But this is the reason why our small asteroid maybe not belong to this family. I'll explain you why. You see, let me see, yes, it's future explorations. Let me return back to a slide. I want to show on this slide of origin of asteroid families what's going on. So we have a collision of planetesimals, or later of planetesimal with a large asteroid, and due to this collision, the planetesimal decayed. And it created many pieces, large pieces and small pieces. But small pieces are small, and it's easy to move it away. And that's why the longer the asteroid family exists, the less small pieces left. All of them were taken away by Jupiter, by interaction with the solar light, and so on, or other collisions with other small collides, much more of them, many small pieces, and they easily and much more often meet with other asteroids. Does matter, large or small, does matter. So that's why the longer our asteroid family exists, the less small asteroids left there. But we know for sure that our asteroids, all of them, our 9 asteroids, are small. That's why, though our asteroid looks like it belongs to Themis family, and it really very, very close to it by characteristics, and it flying it in the orbit there, it should not. It should not be there because of that family is very old. Our asteroid is not. Is small to belong to this family. So that's what our research discovered. So our future explorations about all of them, not only about Fokker family but others as well. In future, what we may do? We may find out period of rotation of an asteroid, and based on repeated, very often made observations, we may make even 3D model of this asteroid. What we need? We need to make a light curve of the asteroid. In average, the brightness of all our asteroids, apart of the first one was much brighter, is 21 magnitude. 21st magnitude is really dark. It requires large instrument. And that's why it is achievable, it's possible, but it requires large instruments. I think not many such telescopes in CYPRUS. There are not many such large telescopes which may make light curve, take light curve of this telescope, of our 8 asteroids, 9, any of them. Size and composition. This is interesting. It's really possible to do. How we may start with composition? We may research spectra of asteroids. So when we find spectra, so all light which collected in one point, we will disperse from blue light to red light and see how it is distributed inside, and it will help us to find out which material this asteroid consists of. If it occurred stony material, then it is bright. And if it is bright, it sends back a lot of light, then we may estimate its size. If it occurred to be black, dark material like charcoal, so very dark asteroid, then it means that this light is collected by larger larger asteroid should be to create so much light, so little or so much. It depends how we want to say. So that's why it will help us to find out size of the asteroid. At least this estimation could be done from the Earth. What is necessary for it? Unfortunately, if large telescope are necessary to make light curve, then to take spectra, we need even larger telescope to make, because of this light which is collected in one point should be spread on large range from blue light to red light. So it's so long, so many photons are required, so much light should come, that to take spectra is definitely more complicated task, but still possible from the Earth. It's not age or limit of observations. Okay, we may find out even landscape which asteroid has. So it has mountains, maybe it has other craters, other asteroids fell on it. It has a lot of small stones on its surface, or maybe it's oblique. So I don't know how to do to find out it. It's very simple. We may make spacecraft imaging of the asteroid and research asteroid, as it is written here, in situ. So arrive to the asteroid and observe what and research what it consists of. We may drill it even to find out which material it has inside and from what it was made. So all this is waiting for future exploration. Obviously, spacecraft is important, and it means that in Cyprus, someone will send a spaceship with a robot, which will make this research and send to the Earth data. So that's what could be done with our 9 already discovered asteroids. So that's our conclusions. So asteroid 2019 AN16 belongs to Fokia family. Asteroid 2020 JW8 maybe belong to Evnomia family, but not sure. And asteroid 2021 CJ48 doesn't belong to Themis family, despite of it is very, very close to it and shares the orbit. It should not, because of this family is old and our asteroid is small. Small asteroids don't live in so long in families. They dissipate and go away. And many of these asteroids, does matter which belong to family or not, they still require new and new exploration, and I believe that a new generation will be interested in it and take the instruments and observe them and make research. Our next Science Cafe was already announced, and if you have questions, you are welcome to ask. I'll be more than happy to answer.
Hello.
Good evening, Hasret.
How are you, Hocam?
I'm okay, Hasret. Thank you.
I would like to say that you have done an awesome presentation, as always you have done. And thank you. You know, I'm not from the astronomy, but I like to read some articles or watch some programs in TV. I would like to ask that I had some time ago, but I don't know if I remember them correctly. They were saying that the asteroids are the sources of protosolar nebula and the
Hasret, I don't hear you at the moment. But I most probably understood your question. Yes, continue. Okay. Hasret wrote that she has the internet issues. I hope she will manage to overcome them. You remember, indeed, that this is the solar system at the beginning, and central part will become the sun, and all the rest will be planets at the end, finally. And to become a planet, the planetesimals were created. So the clumps of gas and dust were gathered together and created this large, relatively large, from many kilometers to hundreds of kilometers size asteroids. And asteroids, planetesimals. And what we have here, so these planetesimals survive till now, not as planetesimals anymore, but as broken planetesimals after the collisions and spreading material in the orbits of main asteroid belt. So that's the reason why we have it. And it is correct. Asteroids are the result of remnants of the beginning of solar system. Other questions? Did I answer you, Hasret? Some more questions? Thank you. Thank you for being with us. Hope you enjoyed, and see you next month.